Dear students, today we are going to study about hydrogen. Now, what does the term hydrogen means? Hydrogen in Greek means water producer. Lavoisier in 1783 established the name hydrogen meaning water producer. In Greek, hydro means water and gen means producer. Robert Boyle he established the elementary character of hydrogen, and Henry Cavendish he prepared hydrogen in the pure state and also described its properties and recognized it as an element. Now coming to the position of hydrogen in a periodic table. Atomic number of hydrogen is 1. Number of valence electron is 1. First element of the periodic table, it is placed in group first A, period 1 of the periodic table. Now here we will come to know about the dual nature of hydrogen, as hydrogen has the simplest electronic configuration of 1. So either it loses one electron and behaves like an electropositive alkali metal, that is group first A. Rest of the elements of this group are lithium, sodium, or it gains one electron and behaves like a electronegative halogen, that is group 17, that is 7th A. Rest of the elements of group 7th A are fluorine, chlorine, bromine, iodine. So now coming to the resultant position of hydrogen. So hydrogen thus shows similarities with alkali metals of group first A, and it is placed above lithium in group first A and also halogen of group 17th A or 7th A above fluorine in 7th A group. Now similarity of hydrogen with alkali metals. The electronic configuration, number of valence electrons are 1. Character, it forms electropositive characters. Its valency is 1 like rest of the elements of alkali metals. Then reactions, it has strong affinity for non-metals, so it forms compounds like water, hydrogen sulfide, hydrogen chloride. Then it acts like a strong reducing agent. It forms water when reacts with copper oxide. Then similarity of hydrogen with halogens. Again electronic configuration. One electron is less than the nearest noble gas. Then the character, electronegative character is exhibited. Valency, again electrovalency and covalency is exhibited. Then atomicity, it forms diatomic molecules, two atoms linked by a single bond, that is H2. Here again in the diagram we can see as hydrogen, the lightest element having atomic number 1, then again dihydrogen containing two atoms in one molecule and represented as H2. Then position of hydrogen is anomalous in periodic table, again with alkali metals and halogens. Again in modern periodic table it is placed in the first group. Now hydrogen, the most abundant element in the universe, that is 70% 70% of the total mass of the universe. 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% 70% Most of the giant planets, Jupiter and Saturn, it consists mostly of hydrogen. It is the third most abundant element in the Earth's crust, found in minerals, oceans, and other planets. Now, we are going to study how hydrogen is prepared by the action of dilute acid on metal. First of all, we will see what is the statement for this reaction. Metal plus acid, salt plus hydrogen. Now, one of the methods that is used in the lab to prepare hydrogen is by action of dilute acid on zinc. The reaction is zinc plus dilute hydrochloric acid gives zinc chloride plus hydrogen. Now, what are the reactants used over here? First, granulated zinc in flat bottom flask, and second, dilute hydrochloric acid which is added through the Thistle funnel. Now what is done? Granulated zinc, it is placed in flat bottom flask and hydrochloric acid or dilute sulfuric acid is added slowly from the Thistle funnel or dropping funnel. Now what do we see? A brisk effervescence is seen with the evolution of hydrogen gas. Now how it is purified? For purification, as we know that granulated zinc, it is impure. So on treatment with dilute hydrochloric acid or sulfuric acid, it evolves in traces which are gaseous impurities. These impurities, they are removed by passage of impure gas through 3 washer bottles and a U-tube. Now 3 washer bottles. In washer bottle 1, it contains silver nitrate solution which absorbs impurity arsine and phosphine. Then the washer bottle 2, it contains lead nitrate solution which absorbs impurity hydrogen sulfide. And washer bottle 3, it contains potassium hydroxide solution which absorbs impurity nitrogen dioxide, carbon dioxide and sulfur dioxide. And U-tube 4, it contains anhydrous calcium chloride which absorbs impurity moisture. Now the precautions which are taken during this procedure is that no leakage of gas should take place and no flame must be near the apparatus. Hydrogen, it is collected after all the air in the apparatus is allowed to escape. Now the Thistle funnel which is used in this procedure, it should dip below. Now the question is, can we use concentrated sulfuric acid and pure zinc in the preparation of hydrogen? Like zinc plus dilute sulfuric acid, we know that it gives the salt zinc sulfate and hydrogen gas is evolved. So now concentrated sulfuric acid, it cannot be used in this process because it acts as oxidizing agent and also it gets reduced to sulfur dioxide. Now the reaction for this is zinc plus concentrated sulfuric acid. The first product will be zinc sulfate plus water plus sulfur dioxide. Now, pure zinc, it cannot be used in this process. The reason is it is non-porous and reaction will be slow. The impurities in zinc, it helps in constitute of electrochemical couple and speeds up reaction. Now we are going to discuss the industrial method for preparation of hydrogen gas, that is the Bosch process. Now in the step 1, the reaction in which the production of water gas takes place. When coke, it reacts with steam at 1000 degrees Celsius, carbon monoxide plus H2, that is water gas, is formed. Then after that, here the reactants are white hot coke and steam. The temperature is around 1000 degrees Celsius. The process done over there is passage of steam over white hot coke, that is carbon. Then in step 2, the reaction that takes place is reduction of steam to hydrogen by carbon monoxide. Here the reactants are water gas and excess steam. The temperature maintained over here is around 450 degrees Celsius. The catalyst involved are iron 3 oxide, that is Fe2O3, and promoter chromic oxide, that is Cr2O3. As I have explained earlier also, that promoters are those which increase the efficiency of catalyst. Then the process done over here is excess steam is mixed with water gas and passed over a catalyst at elevated temperatures, where carbon monoxide is converted to carbon dioxide with a further yield of hydrogen. Now, in step 3, the separation of carbon dioxide and unreacted carbon monoxide from the above mixture takes place. Now, how the carbon dioxide is removed? By dissolving mixture in water under pressure, that is 30 atmospheres, or by using caustic potash solution. Then how carbon monoxide is removed? By dissolving mixture in ammonical cuprous chloride solution. Now here we are going to discuss the general methods of preparation of hydrogen from cold water. Potassium, sodium and calcium. These metals, they are highly reactive metals. When they react with cold water, they liberate metallic hydroxide plus hydrogen. Now here we can see when sodium is reacting with cold water, sodium hydroxide and hydrogen is formed. With lots of energy it is given out. The reaction is violent, but it is less violent Then the reaction when potassium reacts with cold water, as potassium is more reactive than sodium. This method of preparation of hydrogen is not used because the sodium melts into globules and it darts about in the water, so the collection of hydrogen becomes difficult. Therefore, the sodium is wrapped in a wire gauze and used in the above preparation. Now, the other methods for preparation of hydrogen gas is by electrolysis of water, in which acidified water on electrolysis liberates hydrogen at the cathode. Another method is preparation of hydrogen from natural gas, methane, that is present in natural gas, which is obtained from petroleum. It reacts with steam in presence of catalyst nickel, and at temperature 800 degrees Celsius it gives carbon monoxide plus hydrogen gas. Some of the important chemical properties of hydrogen. First, combustibility. Hydrogen is a inflammable and highly combustible gas. When it reacts with air, it gives pale blue flame and forms water. The reaction is hydrogen plus oxygen giving water. Then reaction with metals. It reduces metal oxides to metals when heated. In this, we can see that when copper oxide reacts with hydrogen, in which removal of oxygen takes place, thus there a reduction of copper oxide to copper is taking place. Now we are going to study about oxidation and reduction reactions. Oxidation reactions are those reactions which involve addition of oxygen as well as removal of hydrogen. On the other hand, reduction reactions are those reactions which involve removal of oxygen as well as addition of hydrogen. Now, here is the example: H2S plus chlorine giving hydrogen chloride plus sulfur. Now we have to identify oxidation and reduction over here. Here we can see the oxidizing agent chlorine. It removes hydrogen from hydrogen sulfide. So which is hence oxidized to sulfur. Thank you so much for watching this video. Dear children, hope you will watch and observe very carefully and clarify all your concepts. Thank you very much again.